This is not a factory. This is not a warehouse. This is not even a power plant. This 6-story tall structure is the heart of one of the most advanced ships ever built. You are looking at the engine room of a $200 million megaship, so massive that workers can literally walk inside the engine while it's being assembled. This single machine turns a propeller as tall as a 2-story house, and that propeller pushes a floating steel city across entire oceans. But here's what makes this even crazier. Just to start this engine, it consumes 100,000 liters of fuel. That's not to run it, that's just to wake it up. And the fuel tank? It's so large that 6 Olympic-sized swimming pools could fit inside it. And this entire ship is built piece by piece by more than 10,000 workers, electricians, welders, engineers, and specialists who train for years just to work on a single system. Because on a ship like this, there is no room for error. A single mistake can shut down a ship carrying billions of dollars of cargo, or worse, cost lives. That's why every bolt, every weld, and every system is tested again and again before this ship ever touches open water. Before this ship can sail, it has to pass hundreds of tests. Pressure tests, vibration tests, thermal tests, emergency shutdown tests. High-stakes warning, because once this ship leaves port, there are no second chances. Every voyage costs millions of dollars. Every day it sails, it burns fuel worth more than most people earn in a year. So why build it this way? Why spend $200 million on a single ship? Because ships like this are the backbone of global trade. Nearly everything you use has spent time on a ship like this. And this one is built to move more cargo with fewer emissions than almost any ship before it. And that's where this story really begins. One of the world's largest shipping companies, CMGA-CGM, made a bold decision. They didn't want to just build another massive ship. They wanted to build the world's largest eco-friendly container ship. Not powered by traditional heavy fuel oil, not powered by diesel, but powered by LNG, liquefied natural gas. This single choice would force engineers to completely rethink how a megaship is designed, built, fueled, and operated. And the result would become one of the most advanced container ships ever created. Let's talk about scale. This ship stretches 400 meters long. That's the length of 4 football fields placed end to end. It's 61 meters wide. It's taller than famous historical towers. And fully loaded, it weighs around 70,000 tons. That's the weight of 7 Eiffel Towers, or over 11,500 African elephants. And that's before counting the cargo. The ship can carry more than 2,300 massive containers. If you placed those containers in a single straight line, they would stretch over 150 kilometers. That's longer than most people drive in 2 hours. But building one ship like this is already difficult. CMGA-CGM didn't want 1, they wanted 9. Normally, building a ship of this size takes around 18 months. CMGA-CGM gave the shipyard just 2 years to build 9 ships. That meant the clock was always ticking. Every delay would cost millions of dollars. Every mistake could destroy months of work. To make this possible, engineers turned the shipyard into what looked like a small industrial city. The shipyard stretched nearly 4 kilometers long. More than 6,000 workers operated around the clock, day shift, night shift, non-stop. Electricians, welders, crane operators, engineers, quality inspectors. Every worker had one goal: keep the giant moving forward. So how do you build 9 megaships in record time? You don't build them as one piece. You build them like a giant Lego set. The entire ship is constructed in massive sections called blocks. Each block is built separately, fully wired, fully piped, partially equipped. Then, only at the final stage, these enormous blocks are lifted and joined together. This allows thousands of workers to build different parts of the ship at the same time. It's the only way a project this large can even be attempted. Everything starts with steel. One single ship requires 12,660 massive steel sheets. These sheets are cut using specialized industrial lasers. These lasers reach temperatures of 18,000 degrees Celsius. That's nearly 3 times hotter than the surface of the sun. To the laser, thick ship steel is like butter. In total, engineers cut over 880 kilometers of steel strips for just one ship. That's enough steel to stretch from one major city to another. These sheets are then welded together to form the giant blocks, some the size of a room, others as tall as small buildings. Even more impressive, before these blocks are installed on the ship, workers already install pipes, wiring, and internal systems inside them. So when a block is lifted into place, it arrives like a partially finished building. One of the heaviest sections is the stern, the rear of the ship. It's built from 5 massive blocks. Together, they weigh around 790 tons. That's about the weight of 2 full train engines. 2 gigantic cranes are required just to lift it. But here's the scary part. When that block is lowered into place, engineers must align it with millimeter precision. A mistake of just 1 millimeter can destroy months of work. Imagine lowering a building-sized object and needing to be accurate to the width of a grain of rice. That's the level of precision required. Once the blocks are locked into position, the exhausting phase begins. Welding. Not a few joints, not a few seams. For one single ship, workers complete over 1,250 kilometers of weld line. That's enough weld line to stretch between 2 major cities. Every single weld matters, because out on the open ocean, waves don't forgive mistakes. Pressure doesn't forgive shortcuts. Salt water finds every weakness. That's why every weld is inspected again and again and again. Only when inspectors sign off does the ship move to the next phase. And now we reach the most revolutionary part of this entire project. This ship does not run on diesel. It does not run on heavy fuel oil. It runs on LNG, liquefied natural gas. This is a massive shift for global shipping. Compared to traditional fuel, LNG produces 99% less sulfur dioxide, 91% less air pollutants, and 20% less carbon dioxide. For an industry that moves most of the world's goods, this change alone has enormous global impact. But using LNG introduces a problem so extreme it nearly stops the project before it begins. Liquefied natural gas sounds simple, but to become liquid, natural gas must be cooled to minus 161 degrees Celsius. Cold so extreme it can shatter steel, cold that instantly freezes human tissue, and cold that makes ordinary ship design impossible. So engineers had to rethink everything. They started with the tank itself. This is not a simple container. It's a multi-layer cryogenic system. The inner membrane holds the LNG. It must remain flexible at minus 161 degrees Celsius. Because if it cracks, LNG escapes instantly and expands over 600 times as it warms. That expansion creates massive pressure, so the tank cannot be rigid. It must move with the ship, while maintaining perfectly sealed. The insulation system is a temperature war. Around the membrane is thick insulation. This insulation keeps heat out and the LNG cold inside. Even 1 degree of warming increases pressure, so temperature control is constant. Sensors cover every surface. Thousands of data points update every second. If any reading drifts, alarms trigger immediately. But storage is only half the problem. because LNG must also reach the engine, still at -161 degrees Celsius, through a ship that bends, vibrates, and moves non-stop. Any leak here would be catastrophic. So engineers added multiple containment layers and designed fail-safe after fail-safe, testing under conditions harsher than the ocean itself. Because once this ship leaves the dock, there are no second chances. Storing LNG is step one. To move the ship, it must become gas again. This process is called regasification. But warming it too fast causes instability. Warming it too slowly starves the engine. So temperature and pressure must be perfectly balanced. This happens inside the gas valve unit, the most sensitive fuel system ever put on a ship. From here, gas flows to the engine. And this engine is not normal. It stands over 6 stories tall. It weighs more than 2,000 tons and produces more power than a small power plant. This is a 2-stroke marine engine. Each cylinder is large enough to stand inside. Each piston weighs as much as a small car and moves nearly 100 times per minute. The engine can run on LNG or conventional fuel and switch between them while sailing. This flexibility keeps the ship moving no matter where it is. The engine turns a single shaft. That shaft drives a propeller taller than a house, each blade carved with extreme precision, because inefficiency here wastes millions in fuel, and vibration here destroys engines. So everything is balanced to microscopic tolerances. Even a millimeter matters. Once powered up, the engine never truly rests. For weeks at sea, for months, carrying tens of thousands of containers across half the planet, all powered by controlled explosions happening thousands of times every hour and monitored constantly. Because if the engine fails, the ship becomes helpless and everything on board depends on it, which is why this engine is tested beyond reason, before the ship is ever allowed to sail. After nearly a year and a half of non-stop work, the ship finally leaves the dock. But it's not done yet. For the next 15 days, the vessel undergoes intense sea trials. Everything is tested: engine speed, fuel efficiency, emergency shutdowns, steering response, structural strength. Even the anchors are tested. A single link of the anchor chain weighs 300 kilograms. The full chain weighs as much as 60 African elephants. If anything fails here, the ship goes back for repairs. There are no shortcuts. The trials are a success. The engine performs flawlessly. The LNG system remains stable. The structure holds under stress. Against impossible deadlines, the shipyard delivers not 1, but 9 ultra-modern container ships in record time. Each one cleaner, each one smarter, each one more efficient than the last generation. But this story isn't really about steel or engines. It's about people. Thousands of workers, welders working through the night, engineers solving problems no one had solved before, crane operators lifting building-sized blocks with millimeter precision. This ship exists because humans refused to accept limits. They took a vision and turned it into a moving steel mountain that now crosses oceans every day. These ships now carry the world's goods across relentless seas with fewer emissions and greater efficiency than ever before. They prove something important, that even in the modern world, engineering still matters, human determination still matters, and when people work together at scale, they can move mountains, or, in this case, move them across the ocean. We hope you enjoyed this journey from the Planetary File. If this story amazed you, share it with someone who loves engineering and innovation. Thank you for your incredible support and comments. We'll see you in the next amazing story.